Hi again, and this is Deepak here, and now we are going to discuss about congruency and similarity. What does these two terms mean? And what is the importance of these two terms, especially in a topic by the name of geometry? What do we mean by congruence and similarity? To explain it in a very simple way, what we can say is, say if there are twin brothers, right? If they're twin brothers, this is twin brother A and twin brother B looking at each other, or standing in front of me and telling me to identify which one is whom, and I cannot identify them, then we can say that these two twins are congruent to each other in every which way. If we put these figures above one another, then we cannot distinguish between the two. Then we can say that these two figures are congruent to each other. Okay. So when we say congruent, the angles as well as sides, they are all equal to each other. So angles of one is equal to angles of the other. Okay. And when I say similarity, okay, when I say similarity, so I take a very small example here. When I take of similarity, if you have become older and you're seeing a younger version of yourself in a photo, then these two figures, the younger version and now the older version, they are similar to each other. So we can say that congruent shapes are exactly the same shape and same size, and the sides are also equal, the angles are also equal. But in similar shapes, they are same in shape but not in size. You notice here that the other figure, the blue figure here, is a dilated version of the pink figure. So same shape but different sizes. Now, what do we infer from this? Okay, we can say that all congruent shapes, they are similar, but all similar shapes may not be congruent. Right. So we can exemplify this that if two sides, if the sides are say A, B, C, D here and E, F, G, H here, right? We can say that in this case, if here also the sides are A, B, and C, D, then AB is equal to CD, okay? BE is equal to DF, EG is equal to FI, something like this, and GA is equal to IC. But that is not the case in similarity. We can just say here that the ratio of the sides is always a constant number. So we can say that AB by EF is equal to BC by FG, CD by GH, AB by EF is equal to BC by FG, and so on and so forth. So this is a very important relation for similar shapes. Okay, now to call a similar shape, all we need to say, all we need to prove is that the two angles, I mean, the angles of both the figures must be equal to each other. That's all we need to do. If we prove that, then we can say the two figures are similar in shape, right? But if we prove in congruent shapes, if we prove that the sides as well as angles are equal, then they are congruent in shapes. Okay, there are various kinds of congruency. Okay, I have written it down in front of you, right? In acronym format. This is SSS congruency, which means sides of three of both of these triangles are equal to each other. So side AB is equal to side EF, side BC is equal to side FG, and side CA is equal to side GE. So these three sides are equal to each other. That means these two are congruent in shape due to the SSS rule. Similarly, in the second one, it is SAS rule, which means side angle side, which means two sides of one triangle is equal to two sides of the other triangle, and the included angle between those two sides are equal to each other, then these two figures are congruent to each other. Okay, so that is side angle side. A refers to angle. Okay, then the third one is ASA. ASA means angle side angle. So we can say that if one side is equal to the other side and the included angles enclosing those two sides are equal to each other in both these figures, then we can say it is a case of angle side angle congruency. And in fourth one, we can say that in a right angle triangle, if the right angles are equal and the hypotenuse are equal, and one of the other sides is also equal, then we can say this is a case of right angle, hypotenuse, and side congruency. So right angle, hypotenuse, and a side congruency is the fourth kind of congruency. Okay, so we can use these things to calculate various dimensions given in an exam. So suppose if you are given two triangles here. Okay, so two triangles are given, say A B C and ADE. Now notice here that in these two, small triangle and bigger triangle, both the angles are same here. This angle is equal to both of them. This angle B is equal to angle D because they are right angles. And the third angle is also equal. So we can say triangle ABC is similar to triangle ADE. When that happens, we can say AB by AD, we can write it like this: AB by AD is equal to BC by DE is equal to AC by AE. So there is a one-to-one correspondence. So this is how you write the rules of similarity after having proved that the two triangles are similar. Now using this, properly putting the values, we can get the value of X as well. This I leave it for your exercise. Right? So thank you so much. We will do some more good concepts in my next and subsequent class. Thank you so much.